In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. Lurking in the shadows of the solar system are worlds so chemically active and misshapen that they border on the bizarre.
I think the most shocking thing was how very different the solar system is.
These are the moons surrounding the planets of the solar system. Moons that were once either unknown or considered afterthoughts are now on the cutting edge of astronomical exploration.
What was surprising, that they all didn't look like our moon. The so-called minor members of the solar system are not of minor interest.
What surprises await us on these alien moons? Our solar system has always been fertile ground for science fiction writers. But with exponential advances in telescopic technology and close encounters by unmanned probes, the curtain has now been lifted on a new ballet of moons.
Most of which are going one way around, some of which are going the other way around, all at different rates, passing one another, the inner ones passing the outer ones.
For nearly half a century, it was believed the solar system was home to only 32 moons. They ranged in size from Jupiter's moon, Ganymede, larger than the planet Mercury, to small asteroid-shaped ones like the Martian moons, Phobos and Deimos. That number has exploded. In 2007 alone, scientists announced the discovery of 20 new moons around Jupiter, 1 around Saturn, and 3 around Neptune.
What happened is astronomical telescopes had available to them what are called CCD cameras. So these are digital cameras that almost everybody has nowadays.
It's difficult to hold astronomers to an exact number of moons in the solar system. As cameras become more sensitive and telescopes more powerful, more moons reveal themselves. Moons are classified in 2 distinct ways. Those, like our moon, travel in nearly circular orbits above their planet's equators and are called regular moons. While our moon formed from an impact, all other regular moons coalesced from the gaseous stew surrounding their parent planets, a process known as accretion.
The classic example of regular moons would be the Galilean moons of Jupiter: Io, Europa, Ganymede, and Callisto. The material that is going to form Jupiter too, but extended a little bit, that material accumulates into the moons.
Moons that follow elongated orbits, highly tilted to their planet's equators, are called irregular moons. Most of these move in retrograde orbits, clockwise if their planet rotates counterclockwise. Phoebe, the newly discovered moon orbiting Saturn, is a perfect example. She began her celestial life as an independent traveler, orbiting the Sun before being captured by the more massive Saturn. Whether regular or irregular, moons must fall within the gravitational reach of their parent planet. The limit of these orbits is known as the heliosphere. This phenomenon is named after George William Hill, an American astronomer from the mid-1800s.
So a heliosphere is this region around the planet that moves along with the planet, inside of which the gravity of the planet overwhelms the gravity of the Sun.
The moons of Mars, Deimos and Phobos, operate very differently within the heliosphere.
If the planet is rotating faster than the moon it orbits, like Deimos, the tidal forces between the two actually shove Deimos out further and further. Phobos, on the other hand, is rotating faster than Mars rotates.
These small moons were discovered by American astronomer Asaph Hall in 1877. He named Phobos after the Greek god of fear and Deimos for the god of terror. Tom Duxbury was part of the Mariner 9 mission that first photographed the two potato-shaped moons in November of 1971.
This was late at night in a cold, rainy, dark, dreary day, and I looked at this and I turned the picture sideways. It looked like a skull. And it was such an eerie thing.
Phobos is in a death spiral. It orbits just 3,700 miles from the Martian surface, closer to its host planet than any moon in our solar system. If our own moon were as close to the Earth as Phobos is to Mars, it would look 20 times larger.
Its orbital period would be in hours, not days like it is now, but hours. And at full moon, it would fill the sky.
The daily tides, would rise and fall tens of feet, if not hundreds of feet. And so the Earth's moon would eventually crash into the Earth in such a situation.
Phobos's predicament is caused by a process known as secular acceleration. As Phobos races faster than Mars rotates, a tidal bump is raised on the Martian surface. In the process, Mars yanks Phobos closer to its surface with each orbit. The struggle between Mars and Phobos is similar to the dynamics of a simple game of tetherball. Imagine the ball as the moon, the pole as the planet, and the rope between the pole and the ball as the planet's gravitational pull.
What we see is that the gravity would pull the moon in such a way that it speeds up. It goes faster and faster, and it works its way until it eventually hits the pole. That's exactly what's happening to Phobos. Phobos is going around Mars faster than Mars rotates. That tidal interaction is pulling Phobos in closer and closer and speeding it up in its orbit. In about 50 million years, we expect Phobos to be pulled in so closely it will impact Mars and disappear as a moon of Mars. On the other hand, Deimos, the further out moon, is going slower than Mars rotates. And so it's unwinding the string in the opposite way. And what we see is Deimos is going further and further away from Mars. And eventually Deimos will be pulled away from Mars by the gravity of the sun. So over time, Mars will become moonless.
Because Phobos outpaces the rotation of Mars, it appears to rise in the west and set in the east.
Instead of the planet turning quickly under it like our moon and most other moons, and thus having it rise in the east and set in the west, it races ahead of the rotation of the planet, and so it comes up on the western horizon and races ahead and sets on the eastern horizon.